Hello, it's Keith here, and this is lesson 18 of the simple series of my 68000 assembly programming tutorials, and we're looking at sprite clipping again on the Genesis again. Now last time we didn't really use sprites, we were kind of lying to ourselves, and we were using the Tilemap. That makes things nice and easy for us. We don't need to worry about hardware sprite numbers. It does mean that we have the difficulty that we move in nasty jerky 8x8 blocks, whereas now we are using proper hardware sprites. So we've got our Chibico character here, and it's made up of 8x8 pixel hardware sprites. Now the Genesis can do larger sprites, but for simplicity I'm just using the 8x8 ones to match the Tilemap layout. And you can see our Chibico can go partially off the screen on all sides, which is the same as before, but last time it would move in a very jerky fashion. Now this Chibico character, the graphic here, is being made up of multiple hardware sprites, and if we get our calculator up here, our graphic is basically 48 by 48, and this is 6 by 6 tiles. So if we do 6 times 6, you will see that this is 36 in decimal, that is 24 in hexadecimal, and uncoincidentally you will notice that the register D5 is showing 24, and that's because D5 is being used to track the hardware sprite number. The point I'm making is that as our Chibico goes partially off the screen, if I select the window correctly, you will see that this amount in D5 here is going from 24 and it's going down, eventually getting to 0, and that means that as our sprite is leaving the screen, the number of hardware sprites required to draw it is being reduced. That's part of the cropping function. So we could make our sprite disappear visibly from the screen without using any kind of calculations, but by using this calculation routine we're actually able to reduce the number of hardware sprites we're using. We can allocate those hardware sprites to something else. So that's part of the code. That's what we're doing today. So today we're just going to look at the changes to the code. We're not going to look at all of the code itself. So if you need to know about the details of the cropping routine, the logical units I use, things like that, please see the previous episode which I covered all of that. I'm not going to discuss it again because I'm tired of saying it over and over again in all of these lessons. So please take a look there. Anyway, let's go over to our code and let's take a look. Okay, so we've changed slightly the size of the screen here just to compensate for the logical units and the cropping. Our sprites need to be calculated to be up to 1 sprite off the screen. Now our sprites are 8x8, and our calculations for logical units is that 2 pixels equals 1 logical unit. So an 8x8 sprite is 4x4 in logical units. So you can see we're making some adjustments to our screen for that. So that's what we're doing there. Now our cropping routine hasn't seen very many changes actually. Basically the only thing that has changed is that now our X and Y calculations, they were rounding before to a whole tile when we were having to crop things. Now they are calculating the correct offset for the remaining sprites so that things will move smoothly as sprites start getting removed. So there's a couple of extra lines there for the X position and a couple of extra lines there for the Y position, and that's just calculate the offset when some parts of the sprite need to be removed. So that's what we're doing there. The bitmap data itself is the same as we used before because we're using those 8x8 tiles to build our sprite up with. We're using the same bitmap data in the same layouts. There's no changes there. All that has changed really is our draw sprite routine. Now our routine starts here, and this is basically the same as it was before. Basically what we've got here is we are loading in the first tile number that we're using to draw our sprite to the screen, and the combination of tiles, we'll use consecutive tiles for our graphic. Our width and height is 24 in logical units, that's 48 in pixels, so we will convert that to tiles later. As before, our do crop will calculate if there's anything to draw and set the carry if there isn't, and we'll just give up and go away. When we get to the actual routine that's going to set the sprites, we're just converting them all to bytes. Our X, Y, width and height are all bytes. We then need to convert the X and Y from logical units into pixels, so we're effectively multiplying them here by 2 here because there's 2 pixels for 1 logical unit, and that's how we're doing things. Now we are adding 128 minus 8 and this to our X and Y position, and this is because the first visible pixel of our screen is 128, 128, but to allow for the partial off screen we might want one of our sprites to be just 1 pixel on screen, so we're subtracting 8 from the 128 by 128 position to allow our sprites to be partially off the screen there. What we're then doing is we're changing the width and the height from logical units into tiles, because although our sprite's drawn at a pixel per pixel position, we still need a multiple of tiles because we're using 8x8 sprites. So we're converting by dividing by 4 here, converting from logical units to a tile count here, and we're giving up if that results in 0. We're then setting the priority bit of our tile number here, and we're going to transfer this into our graphic. Now, D5 is going to be used to store our hardware sprite number. So we're starting at hardware sprite 0 and we're going up. Now, if we were doing multiple graphics to the screen, of course, we would need to continue from the last used hardware sprite number, because of course the limitation, if you will, of hardware sprites is one hardware sprite can only appear in one position during one frame redraw. So if we try and use hardware sprite 0 in 2 positions, the second one will override the first. That's why I find using tiles more simple for the beginner. So we're using D5 as our tile number count, and we're setting it to 0 here because we're assuming there's nothing else on the screen yet. And then what we're doing here is we're subtracting 1 from our width and our height, and that's just so the dbra command works correctly. Okay, now we are calculating the sprite position. Now each of the hardware sprites uses 8 bytes in VRAM. So we're multiplying the hardware sprite number here, transferring it from D5 to D2, and then we're multiplying that by 8, and then we're adding D800, which is the hexadecimal base of the table of data that defines the hardware sprites. We're then selecting that VRAM destination using this prepare VRAM subroutine, and what we're going to do here is we're going to set the hardware sprite. So we've now selected the current hardware sprite, so we're adding 1 for the next hardware sprite. The reason we're doing this is we need to set each hardware sprite to point to its next hardware sprite, basically forming a chain that the hardware will draw to the screen, and the last hardware sprite needs to point back to the first. So that's why we're adding 1 to the hardware sprite number here, because we've already calculated the VRAM destination for this hardware sprite number. Okay, so we're going to transfer a series of words to VRAM, 4 of them, 8 bytes in total. So we're transferring the vertical position first, the width and the height, which is just going to be 0 in this case because we are just using the smallest 8x8 sprite. We are setting the link to the next sprite, and that's going to be transferred from D5 here because we've added 1 here. We're then specifying the color palette, the priority, and the sprite number. Now we're transferring this from registered D7 here, which is the base of the sprite. We set this at the very start here to 256 plus 1. That's the tile number of the first Chibico tile that we need to use. We're then specifying the horizontal position. We're transferring that from D1 here. And then what we're doing here is we are adding 1 to the tile number because we're going to use the next tile for the next drawing. We're then adding 8 to the horizontal position, 8 pixels moving across the screen by 1 full tile, and we're repeating for the next hardware sprite across the screen. Now once we've done one entire line, there's 6 tiles to create one line of our Chibico graphic, we're going to need to move down the screen. So what we're doing here is we are first going to add any tiles that we need to skip, because if our Chibico is partially off the screen, we're going to need to skip some of the tiles, and that's what we're doing here. If sprite hclip is non-zero, we're adding that to the current position within the tiles that we're drawing to the screen. Okay, so we've now drawn one full line of our graphic. So what we're doing next is we're adding 8 to the Y position, moving vertically down to start the next line, and then we're restoring D1 and D3 from the stack. Now D1 is the X position and D3 is the width of the sprite in tiles. So this will we're basically moving across, drawing all the sprites, and then moving down the line and moving across and then moving across and repeating until we've finished our sprite. But we're not quite done, because even though we've got our complete Chibico onto the screen, we need to set the next hardware sprite number to point back to the start of the list, because the last one needs to point to the start. Otherwise the hardware sprites won't work correctly. So what we're doing here is we're effectively setting one dummy sprite, if you will, just setting all of its parameters to 0. Any consecutive writes will go to the next VRAM address here. So this is just setting the next sprite to be an off-the-screen sprite that points back to the start. Now, alternatively, we could have remapped this byte of the last sprite, but it didn't seem worth it for this example. It's just setting this link pointer to the start of the list again for the hardware sprites to work, and that's how we've done things. Now, of course, this routine here will only run when there is a hardware sprite that is required. We have changed our X and Y position and our width and our height using this do crop, and that's how we've got that ability that if the hardware sprite, if our Chibico graphic starts going off the screen, as you can see here, D5 will start going down. So it's gone down to 1E here. If we go back up here, and then it will start going down here. And you can see if we position it just right, there's just one pixel, maybe just one there's just one tile worth of graphic on the screen there. And so now we're down to a single hardware sprite, and that's what that cropping routine is allowing for us. So there we go. Anyway, I hope you've enjoyed this. Hope you found it interesting. As I would say, you can go to my website, download the source code, download the build scripts, and do whatever you want with it. If this is in some way useful to you in your own project, go ahead and have some fun with it. And if it's not useful to you, then maybe you can crib a few bits of the code and find some benefit to it that way. As I say, you're welcome to use it in anything you can, even if it's commercial, because I don't think they're particularly amazing examples, and I'm sure if you've done the work to earn money from it, I'm sure you've earned it. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.